You're listening to STEMxm, where women in science, technology, engineering and mathematics share their stories of success, overcoming barriers, and breaking the glass ceiling. And now, your host, Mel the Engineer.
Hello everyone, and thank you for joining me today for episode 11 of the STEMxm podcast. I'm your host, Mel the Engineer, and on this episode we have Jen Scmidt. Jen came to the show by way of one of our first guests, Lindsay Neville. Jen is a different type of plastics engineer than Lindsay, so we're going to hear her take on another aspect of this field of engineering. She went to Penn State Behrend, which is the Erie campus. Jen studied plastics engineering technology and graduated in the year 2000. At the time of recording, Jen worked for Beaumont Technologies as a design engineer. She's also an expert certified Autodesk mold flows instructor, and she's been doing that for about 10 years. We're going to get right into the interview with Jen, and I'll be back with you at the end to wrap things up. Welcome to STEMxm. Today I have with us Jen Scmidt. She is a plastics engineer. And Jen, thank you so much for joining us and welcome to the show.
Thank you for having me.
So you went to Penn State. Can you talk to us about the plastics engineering technology program there?
Sure. It was started probably like 27 years ago. It's at the Erie campus, which is called the Behrend College. And I think it developed because of the local plastic industry around Erie and the surrounding areas. I don't think it's the case anymore, but Meadville is a town about 30 miles south of Erie, and it used to be called the tool and die capital of the world. I think, unfortunately, probably a lot of offshoring has happened, and that would probably be somewhere in China right now. But back in the day, this was a big hub of plastics. And they were, I guess, local companies kind of got together and were having problem getting skilled workers. And so the plastics program was born. So I think, like I said, 27 years there now. It is a 4-year degree. I don't know what else to say about it.
So how did you select that as your major? Were you from that area and you were familiar with the program, or did you find it on your own from some other place?
No, I find even today, because the company I work for employs a lot of interns, and I find even the kids going through that program today tend to come from like a 2 to 3 hour radius for whatever reason. When I went through it, I'm trying to think, it would have been, between 10 and 15 years old as a program. So still relatively new. And honestly, I didn't really hear about it until I went to tour Penn State Erie's campus. I kind of knew I'd be going for engineering or at least sciences. And they really talked up the plastics program. And the main thing back in the day, and I'm pretty sure they still hold pretty true to this, is they had 100% job placement. And even all the other engineering majors couldn't say that. I mean, they probably had really high 90s job placement, but pretty much if you graduated from the plastics program, you were guaranteed to get a job somewhere. So that was kind of attractive.
Okay, let's talk just a moment about when you were younger. You mentioned just now that you knew that you were good at science and math. How did you know that? How did you have that confidence at a young age?
Well, I don't know. I guess towards the end of middle school and then definitely in high school, it was just kind of a natural aptitude. Those things came very easy for me. I was always a really decent student. I got really good grades. My parents kind of expected me to. So I don't think there was a lot of options to not get good grades anyways. But things like, literature and history, I had to work towards a little bit more, where math and chemistry and physics just came naturally. As long as I showed up to class, I could get an A really easily without having to do much homework, which was probably an unfortunate thing when I went to college, where, everyone's the smartest kid in the class kind of thing. So it doesn't come as easily. And I think I would have preferred to have some of those study habits earlier on. But I guess if you're kind of asking how I kind of knew I was going to be going down the road of engineering, I just showed an aptitude towards science, math, chemistry. My parents had helped me with college. They kind of made a deal with me that they would pay for it, so I didn't have to worry about loans, but I had to pay them half back, basically. But it was nice not having to worry about financial aid or anything. But in doing so, we had a couple stipulations. One of the things my parents wanted is for me to find an in-state school. And being from Pennsylvania, there's lots of colleges and a lot of fairly decent ones at that in-state. So no reason to go out of state and, get higher tuitions. And the other one was kind of, I had to have a job that I could support myself on. So my mom kind of always, no psychology kind of thing. And not that I'm ripping on that per se, but at the time in high school, I was working at CVS, which is like a local pharmacy. And, a lot of I'm going to call them grownups because I was a kid at the time. A lot of the grownups who would have been in their 20s and 30s had gone to college and even completed it, but they had psychology degrees or something along those lines where, you maybe couldn't get a decent paying job kind of thing. So, they just want to make sure that I thought it through and I picked a major that I could support myself. So I always joke that my mom said, well, we'll help you out with college. Pick your favorite type of engineering. Yeah.
So it sounds like maybe they were a little bit strict, but in a good way that worked out for you well.
It really was, because it's such a hard thing. You start visiting colleges between your junior and your senior year. At that point in time, I was 16. How do you know what you want to do at 16? And quite honestly, I don't even think I knew exactly what engineering was. I knew it would use math and science, but I had no idea that it meant sitting in a cubicle for 8 hours a day. Not that all engineers do that. And I'm actually quite happy with what I do. But, I don't think you really understand what you're getting into. And I think today, people get to job shadow and whatnot. If that was around when I was trying to decide, I wasn't really aware of it.
So talk to us about what happened after you went through school. So you toured these campuses, you decided on Penn State Barron, and you found out that the plastics program had really good placement, and so you chose that path. What happened after that, and were there any internships or co-op programs you got into while you were in school that impacted your career path?
Okay. I should tell you, first of all, I didn't actually outright pick plastics. I actually kind of thought I was going to go into chemical engineering, and I picked it in the worst possible, not the worst possible way. I was very good at chemistry. I liked chemistry. Electrical engineering and mechanical engineering didn't really excite me the way maybe chemistry did. So that's actually what I started out in. And I was roommates with a friend from high school, and she was in the plastics program. Well, I was stuck taking just general engineering classes my freshman year, and she was already in the plastics lab bringing home parts and telling me what she was doing. So it was a couple months into my freshman year, and I switched majors. And the 100% job placement kind of had a lot to do with that, but the fact that she made it look so fun, and they were already hands-on, which I think does set that plastics program apart from other engineering majors. That's kind of why I switched.
Yeah, that's very cool.
Yeah, it's kind of random how you end up where you end up, I suppose. But
sure.
Today that plastic program is run a little bit differently, because things evolve over the years. And the interns we have interns, we have summer interns. Some of the interns stay on and work, 10 to 20 hours throughout the week through the school year. But they also do co-ops now where you can take off a semester or a year and get credits towards that work experience. And I guess they might have had one or two co-ops, but not like they do now. When I went through, it was pretty much, school through the semesters, and then you did summer internships. And pretty much at that time, you didn't really get an internship until after your sophomore year. And I was from a town that was about, an hour and 15 minutes away from the college. So they had a couple plastics companies there because, like I said, there was a local presence. And I got an internship there, which was convenient because I lived with my parents in the summer and worked at one of the local companies. And they were interesting because plastics kind of have, our program can get someone ready for basically any piece of plastics. The majority of it is probably focused on injection molding plastics, but there's blow molding, there's rotational molding, there's all these other things. There's also thermoplastics. Am I getting too deep into this?
Well, that's good. Before
Okay.
you go further, though, could we kind of pause right there and
Sure.
you explain those different kind of sectors of plastics?
Oh, okay. So injection molding, I'm not sure I was prepared to think about this actually. Injection molding basically has a large machine, and they use a screw and a heated barrel. On top of that, there's a hopper that feeds plastic pellets. And then they will rotate through this screw and this heated barrel to melt down the plastic. And then they inject it at very fast speeds into a mold, which is going to be made out of some kind of steel, sometimes aluminum, more often just different types of steel. And there's, a void or a cavity in there, and they basically shoot the plastic at a very high speed into this cavity, and then they cool it. That's how the majority of plastic parts are made. There is blow molding, which a lot of kids' toys, the bigger kids' toys, you go to a frame of reference, and I have small kids, so that's obviously what I think of. But those like playhouses that you'd see in the yard, that kind of stuff is sometimes blow molded, where they kind of extrude a tube of plastic and then a mold clamps around it, and then they inject air to kind of blow that out to the side. So if you could imagine like blowing up a balloon against, some kind of cavity to form something, and then they hold it there till the plastic cools. There is rotational molding, which typically is how something like a kayak would be made. Huge molds, you can imagine, and they'll just rotate it on different axes until like all the molten plastic basically covers all the surfaces and cools it. There's also thermoforming. So if you've ever seen like the packaging, the clear plastic that kind of forms to whatever you're buying. So I can't even think of a product right now, but like a pair of swim goggles. My son just got one. It's not like saran wrap. It's thicker than that. It's the stuff that's always horrible to cut through, with scissors. That is basically like a sheet of plastic that they drape over a form, and they can heat it up and basically vacuum form it, kind of thing. But injection molding is probably the bulk of what people go into out of this program, but they do cover kind of all these other pieces of plastic.
Okay, so the program would touch on everything, but then when someone finishes their degree and gets out to get a job, it's likely that they would end up in one of those specifically. Is that right?
Yes. Yeah. And then so I would say probably 90% of the students probably end up in injection molding just because it's the most common. But technically we would have been exposed to enough of everything that I think you could do anything within the plastics realm with our degree.
Okay. And injection molding is what one of the other guests that we had on the show does, Lindsay Nebel. So anybody listening who wants to go back and hear that episode, they can hear Lindsay talk all about the injection molding side of things. But let's come back to you, Jen. So where did you end up and what kind of things are you working on now?
Well, do you want my whole history or just what I'm doing now, I suppose?
Give us the history. Tell us, the progression and how you ended up here.
Okay. So I guess I'll go back to the internship. So, I interned at a company in my hometown, they made a lot of automotive parts, under the hood kind of components. So, pieces to radiators, things like that. And I interned there. And then when it came back to time to go back to school in the fall, they said I could continue working. And it was just over an hour drive. And, gas was cheap back then because I'm a little bit older. So I decided to stay at home and save some money. And I basically finished my last 2 years working 30 to 40 hours a week. So I'm going to say nearly full time. And going to school full time. At that internship, I also met the man that's my husband now. He also graduated through the plastics program. He was 2 years ahead of me. I didn't really know, he had just graduated the summer I started my internship. So he was starting at that company as a product engineer, and I was an intern. And luck would have it, we got along great. We started dating. I think by November we were engaged, and the next summer we were getting married. So I actually got married the summer between my junior and my senior year of college, which is probably not very traditional. Plus with the addition of all the working all those hours and the commute and everything. So I had an interesting last 2 years of school, I'll say.
Yeah.
Yeah, I worked really hard. And I thought I was going to have a job at that company when I graduated because they had pretty much told me that. So I didn't bother to go to job fairs or anything else that all the rest of the seniors were doing at the time. And then when it was time to actually kind of make it official, I think maybe about a month or two before we were set to graduate, they said they wouldn't be offering me the job after all, financial reasons. Ironically, it was a very good thing that company ended up going under probably 2 years after that, I think. So having both my husband and I there probably would have not been a great thing, especially with everyone else who was displaced in this, tiny little town. So that kind of left me scrambling to find a job. And, I just put my resume out there online and had a handful of interviews. And I ended up getting a job at a hot runner company up in Vermont, where I ended up staying for about 12 years. Do you know what hot runners are?
No.
Should I go into that?
Yeah, please do.
Okay. So the way I always explained hot runners to people was, if you ever get like a Trivial Pursuit game or, anything with all these little plastic pieces, and sometimes you have to break little plastic pieces off this plastic, I'm going to call it like a tree. And then, you throw that piece away. That, what I'll call the plastic tree, is actually called a cold runner. That is how in injection molding you get the plastic from the machine to the cavities, basically. Hot runners do the same thing, but they're heated by various different ways, typically externally. So they'll have heater bands and heater elements around the steel to keep the plastic molten so that you're not wasting as much plastic. So, you have less scrap, less material usage. They're a little bit more expensive up front, but they, over the life of a product could save you money because of scrap and that kind of thing. So.
You're listening to the STEMxm podcast, episode 11, with Mel the engineer. Today's guest, is Jen Scmidt, and she is a plastics engineer. Could you talk to us about maybe a specific item or product that you worked on at that company? And could you walk us through what your responsibilities were?
Oh, well, that's a good question. I worked there for 12 years, so I kind of held a few different roles through those years. So when I was hired as a hot runner designer, which basically meant I designed the layout of the components that kind of go inside this hot runner system, basically.
Hot runner designer sounds very cool.
Well, yeah, I guess it sounds cool. I don't know that it was. Like I said, it's funny how you end up where you end up. I didn't hate the job, but I didn't love it. Like I really liked. Before that, I had done mold design, which is, I think, kind of what had landed me that job. And mold design I found interesting. Hot runners are a little bit removed from the plastic side of it. A lot of the people that worked in the hot runner company were just strictly mechanical engineers. And not that there's anything wrong with that at all. It's just I kind of had stepped away from what I really liked. I went to school for plastics. I kind of still wanted to be around plastics, not so much thinking about steel and that kind of stuff. From there, I moved into an application engineering role, which, inside sales support is what I'll call it. Basically, kind of your liaison between the sales guys and customers and then the designers. And that was a little bit more interesting because it brought me back a little bit closer to plastics. And then after a few years of that, I went into the mold flow team. And that's what I've been doing ever since. And that's, I always think it's funny because I had a few mold flow classes when I was at Penn State. And it's not that I didn't like it, but the program has evolved so much over the last 15 years that the program I learned in college was not the same one that I get to use now. It's a lot more user-friendly now. It was just a lot more difficult back then. So, it's something that if you told me that I would be doing what I'm doing now back in college, I would have laughed at you because that would probably have been the last thing that I would have wanted to do. But now I really like it. The neat thing, and what I do now, so I do mold flow consulting. And I've always done it in what I'm going to call like a third-party consulting fashion, which means I don't own the parts. We don't mold the parts. We don't own the parts. We're not Nike. We're not even the tool shop at that point. It makes it interesting though, because I'm not always seeing the same type of parts. So I'll see medical parts and cell phone parts, automotive parts, car parts, kind of a whole range of different markets and then different kind of plastics too. So you get to see, a lot of interesting things.
Okay, so what does the mold flow team do exactly? And can you describe for us what, like the nature of the consulting? So if you're not touching the product, is your team designing the molds themselves? Like, can you give us a better picture of what's happening there?
I will try. We wouldn't design the molds, but we could help improve them. So mold flow is basically a finite element analysis that simulates the flow of plastic. It is pretty much relegated to injection molding. I think there are programs out there that might do simulation for blow molding, but mold flow is not one of them. So it pretty much focuses around injection molding. So basically, I can tell you where to gate your part, where any defects might be, like air traps and weld lines, which I can get into. We can kind of predict how the part will warp. As plastic cools, it shrinks and mainly it's variations in shrinkage that start to cause warpage. So if you've ever had like an old Tupperware lid that doesn't sit flat, it kind of has that, potato chip kind of thing, that would be warpage. So we can kind of predict that and work on ways to fixing it. I think the real power in mold flow lies in iterations. It's a virtual what if. So what if I move the gate, from this position to this position, or what if I inject it faster, if I, cool it longer, or change my melt temp or anything like this. We can see the effects of it virtually without having to stand at a machine, waste time, waste resin, all that.
So would your team be involved on the front end of a design rather than, after something's already been created, or do people come to you just when they're having problems with a product?
Okay, so that is interesting too, because mold flow kind of works through any point in the product development cycle. Certainly there are some people that only come to us after the fact when they're having a problem, and you can use it to troubleshoot. It changes how you use it a little bit, because at that point, the first thing we'd want to do is run what their existing process is so we can benchmark to make sure that the simulation is matching up to what they're actually seeing. These programs have come very far in the last decade or two with how accurate they are, but sometimes they do miss. And even if they miss on magnitude, the trending tends to be right. So if something is going to warp upwards, the simulation typically predicts that. Now, if it's going to warp 5 millimeters versus 10 millimeters, that's kind of where it could be off. But mold flow would still have value even if it's off, because at least you would get the trending. And if you can cut the warpage in half by making some kind of design change, that 50% reduction tends to hold true in real life. So even as comparative, it's still helpful. But the earlier you can get it into the product development cycle, the more impact it would have. So if your tool is already designed, that pretty much means you've chosen a gate location, and you probably already have a runner layout, runner size, but I might be able to influence some cooling or some processing. But if I can get in even above that with the part designer, we can change gate locations, we can change wall thicknesses, we can change features.
I want to pause you right there.
Oh, no.
You use several terms that I'm not familiar with, and I want to make sure we explain them for the audience. So
Exactly.
Go back and talk to us about, you said gates and runners, and what are these different components that you're talking about?
Okay, so runners would be like that plastic tree that I was talking about. It's basically the melt delivery system, how you get the plastic from the machine and the heated nozzle into the cavities. Typically, in injection molding, they tend to have more cavities, especially if the parts are on the smaller side. So they'll have those basically plastic runners or branch trees, I'm trying to think of the best way to explain it to someone who's not in plastics. Like I said, the Trivial Pursuit pieces, that piece that you would throw away, that is how we get the plastic to the cavities. The gates would basically be the part where you rip the part off of the runner. It is the entrance point from that runner system into the cavity. If you've ever run your finger across the top of, like a water bottle lid, and you feel that tiny little bump in the center, that's gate vestige. That's what's remaining from where that plastic was injected. The downside to being married to a plastics engineer is it's really hard to go shopping, because I can kind of turn it off on the weekends. In fact, I kind of like to. He loves to go around and pick up plastic doodads and say, "Oh, where's this one gated? And look at this," and pick out defects. So, it's always find the gate with my husband. So, but yeah, depending on the type of gate they use, some of them can be really obvious. If you flip over the bottom of like a paint can or a bucket. Sometimes those ones are super obvious. They're huge and there's a big chunk of plastic left behind. Other ones, especially ones that would be gated with hot runner systems, are sometimes almost really difficult to find, which, is another pro to a hot runner system, I suppose.
Okay, you mentioned that the program you use now for mold flow is a lot better than what was around when you went to school. Can you talk to us about that program, and is that something that's taught as you go through the plastics engineering degree program, and how did you become proficient in it?
Yes, it is taught. They have, I don't know how many classes they have now. I feel like we had, I'm going back a ways in my memory. I feel like we had maybe 1 to 2 classes, and I actually, for it not being my favorite thing back then, I even took the tech elective for advanced mold flow, which is really ironic. Glad I did. Back then, like today, you can just import a CAD model into the program and then you mesh it. So for anyone who's familiar with finite element, there's mechanical finite element programs like ANSYS or whatnot, where you apply a mesh to, which basically you're just breaking down the part or whatever you're looking at into a bunch of subdomains or elements to make it easier to solve using these programs, algorithms, or however they do it behind the scenes. Today, you just bring a part in and you can mesh it very easily. You can even mesh it in 3D, which means it has a true 3D volume. If I cut through it, there are, in this case, Moldflow uses triangles and tetrahedrals. So if we're doing a 3D mesh, it's tetrahedrals through the solid part, basically. When I did it in college, you had to build the model from the ground up. And you could basically only do it in triangles, or what I'm going to call planes. They called it mid-plane, which meant instead of representing a 3D volume, you were kind of taking the mid-plane or the mid-surface of the part. And I really wish I could show you a picture because this would make it easier to explain. On, very simple parts, like flat plates or lids, not a difficult thing. It gets really difficult to do it when you have thick and chunky sections. You're not sure which way to model the thickness and how to apply it. And then honestly, back then, that program was just very glitchy. It still has glitches today. Users get kind of used to it. But back then, it would just kind of crash, or it would tell you that you didn't have a node where you needed it to be, even though you were staring at it on the computer. You could see it. The program wasn't recognizing it. And it was just not really as user-friendly. I liked the idea of the simulation, and I liked looking at the results. I just didn't like the, user interface, basically.
And this program you're talking about is produced by Autodesk, right?
Correct.
And
it was its own company. I believe it started in the late 70s in Australia, and it was called Moldflow. But I think maybe like 2007, 2008, Autodesk bought them. So now it's one of their products.
And you have some special certifications for that product, right? Could you tell us about that?
Correct. Moldflow had the same certifications, but they called it different things. So they would call it bronze, silver, and gold. And basically, you would have to go through, there were 3 different training courses. After the first training course, you could take a test and you would be bronze certified if you passed. Their test, you have to have an 80%. So there's no like C students here. You have to do pretty decent on them. And then after you took the next 2 training classes, you could take the silver test. And then after you were silver certified for a full year, you could take the gold test. Now, Autodesk kept that same certification. They've changed the test a little bit here and there, but it's the same gist. So there's still 3 classes. They still have 3 levels of certification, but now they call them associate, professional, and expert. So to become expert, you have to be professional. You have to pass their professional certification, and you have to hold that for 1 year. And then once you do that, you can test for gold, or expert now.
And
I always go back and forth on them. Oh, go ahead.
Do you teach courses on this now?
Well, yeah, that's that's, like I said, how you end up where you end up. I had been using Moldflow for 7 to 8 years when I came to Beaumont. And when I came here, they asked me if I'd be interested in teaching it. And at that point, I was just supposed to be kind of the backup instructor. But about the week I started, their full-time instructor decided he was actually going to go take a job at Autodesk, of all places. So I, instead of being the backup instructor, quickly became their full-time instructor. So I teach those courses now, pretty much to anyone that wants to take them. As far as I know, Autodesk doesn't really do their own training, at least not for this particular program. So pretty much if you want to get trained in Moldflow, I think there's a few other places that you can take it, but a lot of the work comes to us here in Erie at the Beaumont Technologies.
And you do that in addition to your regular full-time job?
Correct. Yep.
You are a busy woman.
Yes. Well, those days I just don't work back in engineering. So I've been at Beaumont now for almost 3 years. And when I started, I was doing a training here and a training there. But now it's starting to turn into closer to, I'm going to say, depending on the month, somewhere between 30 to 50% of my workload. So when I have a training class, that's what I do all day. These classes range between 3 and 5 days, although we offer custom classes as well. So that kind of throws another loop in there. And I just won't work on any engineering projects at that time. We've had so much training lately. We had one large room, but now with the addition of their AIM certification course and some of their development courses, and then these Moldflow courses, we had too much training for us to share one room. So they built my own room for me in the back that holds about 8 computers. So yeah, I just basically have 2 offices now is what I'll say.
Great.
Yeah.
Okay, I want to zoom out from this for a minute with what we're talking about and kind of get at the plastics career in a more general sense. So if you were talking to, say, some young students who were considering going down the path of plastics engineering, maybe they're looking at their options in college and they're thinking about this, what would you tell them? And do you have any specific thoughts on, the different career paths that are available to them with that type of degree? What's your opinion on it, basically, based on the experiences that you've had? What would you say to these people?
Well, I think experience-wise, however I ended up here, a combination of my parents saying, pick your favorite kind of engineering, and just having my college roommate happen to be in plastics program, which kind of, guided me towards that. And then just randomly ending up in Moldflow. I really like what I do. I probably wouldn't change it. Going back, even if I had a chance, I truly like what I do now. The interesting thing about that program is if you want to do anything related to plastics in any way, out of that program, you really could. They have, well, one, they give you a really good base to go from. And then 2, the alumni, I'm sure maybe other programs might say the same thing, but the alumni there is just, it's like your own private little club. If you graduated from that program, I can meet someone who was 10 years ahead of me or 10 years behind me, and you're kind of like immediate family just because you went through that same program. And because of that network and, people getting jobs all over the United States, they have alumni in major companies, Apple, Microsoft, Google, Hewlett Packard. I mean, anything that touches plastic, they probably have an alumni in there. So I think there's a lot of doors open because of those connections, and then because of the knowledge you would have coming out of there. I mean, I focus in simulation, which you definitely could. Some people do part design. So, you would be designing the new plastic toy or, medical products that could save lives or make it easier for surgeons. You could design molds. So if people kind of had an aptitude for any kind of CAD in high school or whatnot, that's kind of an interesting avenue. And then, a lot of those three, all those design functions, you spend a lot of time in front of the computers. But what my husband does is he's a molding manager at a company here in town. And I don't think he's ever sitting down at his desk. And, he's always on the floor with the machines actually running parts. And process engineers basically do the same thing. They're always at the machines, tuning in processes, starting up new products and determining what process would work best for those. So, I think whether you want to be in front of a computer, you want to be on your feet all day, there's all kinds of different options with that.
I'm really glad you said that, because one of my questions was if you saw any skills or strengths that could really help someone in this field, but it sounds like there's different paths that could appeal to very different personalities.
I absolutely think so, because some of the guys I work with at Beaumont, they work out in the lab, and I don't think they could ever sit in an office for 8 hours. But at the same time, I don't know that I could do what they do. So, if you like getting dirty or you like staying clean, that you could go either way. There's options both ways, I think. So, yeah. And I didn't really know what I got into at the time. They had given, the interest spiel when you take the tour at the college, and whatnot. But my first 2 years were they kind of focus heavy on the processing side, and you probably are in the lab a little bit more, which makes it very interesting. That's what kind of pulled me into the program. And I thought, oh, that's maybe what I'd like to do, until we got into the next 2 years, which focused a lot more on the design side. And I thought that was a lot more interesting at the point, So I think it's nice that they expose you to all of it, though, because you don't even know until you get into it, right?
Right. Could you talk to us about the difference that you saw when you got into the real world career? Like, how was working in plastics in your career different than the way you imagined it when you were in school?
Oh, that, I don't know how to answer that question. I think only because those last 2 years, I kind of was working, as I went to school. So I'm not sure that, I think because of that, I kind of already had a handle on what I would be doing. I think that's also why I like design a little bit more, because I was already doing it with my internship that I carried through the year. I don't really know how to answer that, to be honest.
Yeah, no worries. I've just got a few more questions and we can wrap up. Okay, so have you had any mentors that really influenced you along the way?
Absolutely. My former boss at the Hot Runner company, she So I was working as an application engineer, and she was working in the mold flow team. And there was two people in the team at the time, and they wanted to expand and add a third one. And I don't even think I would have just gone out and applied for that job. I was kind of happy with what I was doing, and I wasn't really looking to make a change, and I hadn't really thought about it. But she knew my background. She also went for plastics engineering, but she went to UMass Lowell, which is one of the other big schools that offers plastics. There's three main ones. And we like to say they're a competition because as a college student, you would go to technical trade shows and conferences, and you would deliver papers and whatnot and compete against these other schools to see, who came out on top, kind of thing. And because it's such a small, it's such a unique major, there's not very many places that offer it. But so she went to plastics. She knew my background, and she, kind of pulled me into that group, convinced me that I should apply for the job. She even helped me prep for the interview for it. She knew what they were going to ask, what they'd be looking for, kind of thing. And then when I started, I had mold flow a little bit in college, but you just kind of skim it enough to get exposed to it. You're not, I wouldn't say you're proficient in it, not the way that you are, once you're using it every day, kind of thing. So it was, I'm going to take one step back. So teaching these classes, these mold flow classes, that's where I realized I really lucked out having her there, because these people will come in for these classes, and I have somewhere between 3 and 5 days to, try and dump as much stuff on them about this program that you can. But really what you're doing is you're giving like a high level view. This is everything that it's capable, and you kind of skim everything. You can't really get in depth on any one thing simply because you don't have the time. And we could offer longer courses that take a couple weeks, but no one's manager would sign off on letting them come out to training for that many weeks, especially when competition would offer it still in 3 days, kind of thing. And I think if you have the right aptitude, you can go back and dig in and get very good with this program on your own. But I think if you're the only one in your company that uses mold flow, and you don't have any user that had more experience than you when you go to these, initial trainings, that's a lot of work on them. And if they start doing something incorrectly, you're kind of a novice. You wouldn't even know it. So I took those classes when I started about 10 years ago, but I had the luxury of coming back and working with her. And if something didn't make sense or something didn't seem right, I could just turn around because we shared, a cubicle, and kind of ask her opinions. And she had started using mold flow when she got out of Lowell in the late 80s. So she was a depth of knowledge on this program, and then just, I don't know, just kind of a all over mentor, about, I would go with her. I would go to her with other kind of just general questions, like how would you approach this customer regarding this? If someone was difficult or questioning what you were trying to show them, or didn't understand it, or what would you do in this situation? What's another way I can explain it, kind of thing. But no, I was very fortunate to work with her for many years.
It sounds like she really had an impact on helping your career move forward. Do you have any advice for young people who are looking for ways to accelerate their career and, develop relationships like this that can help them along the way?
You were asking me some very good questions, because I was just very fortunate. Well, I'm going to say at the time, unfortunate to work at a very large company with very few women. So honestly, neither one of us had a great experience as a female engineer at this particular company, which kind of bonded us before I ever even joined that team. That's how I knew her, really, because there was, you could count us on one hand how many female engineers there were out of 400 people. And the corporation, has thousands of people, kind of thing. So that kind of created a bond. So I think she had worked at a company here in Pennsylvania, ironically, but not the Erie area, where it was the exact opposite. She was never treated differently for being a female. They encouraged them. If anything, they probably tried to help them get on, a leadership track kind of thing. So I think when she got to that company and it was the exact opposite, a culture that did not promote women in engineering, and it, didn't feel like a welcoming place either, I'll say. Because of that, I think she personally tried to reach out to the few of us that were there. So, I was fortunate in that regards to have made that connection. How would I have forged that connection if she wouldn't have done that? I don't know that I can actually answer that, I suppose.
Okay, well, let me ask you something else regarding this company that you two are together at that was not very supportive of women engineering. Is there any specific incident that you can recount for us where you or the two of you encountered a problem or a confrontation and how you overcame that, specific to being a woman in that environment?
I don't think it was outright. It was just these minor little things that you didn't necessarily see happening to all your male colleagues. And because we had offices in other countries, sometimes it was a cultural thing. When we would have coworkers come in for trainings or meetings, whether it was from Japan or China, there was 3 of us in the group. 2 of us were females, 1 was male. At the time, the one male had less experience than either one of us, but they would direct all their questions to him. He didn't know the answer. He'd just kind of stare at our boss, my mentor, and she would answer, and then they would do it again. And I think with that, that sadly is a cultural thing. I don't know how you really correct that. Some of the other stuff that, the one that sticks in the back of my mind, because it was one of the last things that happened before I left there, was we were on, it was just the 2 of us in this team at that point because our male counterpart had moved on. And we were on a conference call going over a simulation we had worked on with the campus in Toronto, which is their headquarters. And the engineer out of Toronto, after an hour of a conference call and all this data being going over, was like, "Oh, that's great. I'll run it by so-and-so," who was a male engineer with a mechanical degree, didn't know anything about didn't know as much about plastics as we did. And it was just, kind of a slap into the face to both of us. Like, okay, yeah, go check with him about this simulation because he doesn't know anything about mold flow and he doesn't know that much about plastics. I will say, to his credit, they checked with him and he was like, "I don't know. Why are you asking me? Go ask Jen and Barb. They're the ones that know it." So, I think if you're lucky enough to work with someone that will at least stand up for you like that, but in that environment, there's always people that, take advantage of that too. Like, given the opportunity, they put people down to boost themselves up, basically. So.
Right. Well, I'm really glad to hear that you got the opportunity to follow Barb and work at a place where you both are more supported. And I think this is an important topic, as I'm sure we'll have a lot of women listeners to these episodes. If you're not working in a supportive place, it's probably time to look elsewhere.
Yeah, that's I was trying to think of, if you asked me certain questions, how would I answer them? And I definitely don't want to cast a negative light on that, but sadly, it's going to happen. And I think when I got out of college, I was probably a little naive to the fact. But looking back, I think things even happened when I was in college that I didn't even think twice about, that now as I'm older, it's kind of like, well, that's a little odd. Like maybe I didn't recognize what was going on at the time. And I was thinking, if you asked me, well, what would you do about this, or how you would approach it, how I would answer. And the thing is you can't necessarily fight it. I think you have to be thick-skinned to be able to deal with it. But there's especially when it's a culture within a company, I don't think there's any way to fight that without putting a target on your back. Yeah, so I think you need to decide, do I stay there and suck it up, or do I need to move on?
Every situation is different. I think, it sounds like a lot of what you were dealing with is, unconscious bias, which is difficult to address head on because it's, small, subtle things and nuances that happen.
Exactly. Yep. Yeah, there was nothing outright per se. It was just, and honestly, I had worked at that company for probably like 6 years before Barb would come on. And, I started working there in my early 20s. And I think it was always there, but I didn't notice it right away, kind of thing. But again, when you look back and it's like, yeah, that's kind of odd, so.
Absolutely. Well, I've got one last question for you along a similar line. You're married with kids now, and I've heard some of my classmates previously, they expressed some concern about going into certain engineering areas, being worried about having the work-life balance, basically. Do you have any thoughts or advice on that?
Yeah, I mean, I am very fortunate where I work now. It's just such a nice place to work. So I work at Beaumont Technologies, which was founded by John Beaumont. He is inducted into the Plastics Hall of Fame. He was also one of the founding professors of the Penn State Plastics program. There were 3 professors that started it, and he was one of them. It is, a smaller company. There's, I don't know, a dozen plus of us engineers there. He actually does employ quite a few. Well, we're all Penn State Plastics alumni. All the engineers that work in Erie are basically. But I always joke with my husband, for such a small company, he employs so many plastics alumni. But it's a small family-owned business, and they honestly really treat you like family. And I'm very lucky that I chose to. I have 2 kids now, and after each kid, I took a maternity leave between 8 to 12 weeks, depending which kid. But I knew I wanted to return to work. Stay-at-home moms, I give them all the credit in the world. I actually think that job is so much harder than me being an engineer. I love my kids. It's just, I'm not cut out to be a stay-at-home mom. I worked very hard to get where I am. I like my career. I like that my kids see me working. My son, who's 6, doesn't have a full understanding of what I do, but he knows his mommy is an engineer, and he knows his mommy is very smart, which is a nice thing. And my daughter, who is 2, I'm kind of excited to be, a role model in that regards for her when I get older. But going back to work with kids is trickier. My son just finished kindergarten. They just finished school up last week. And about 2 weeks before, they had like an end of school recital, basically. And where my work is very flexible, and I'm sure they would make arrangements if they could have. I think I was teaching a class that week, and when I'm teaching, I can't exactly leave people that came from out of town high and dry. So I had to miss that. But on the other hand, he plays t-ball now, and I have about a 35-minute commute. So for me to get home, get him to his t-ball games, I have to leave work early on those nights. And they don't bat an eye at it. I also come in early. I work through lunch or whatever I need to do to make up the time, but they're very flexible. When I first started there, I didn't have too many sick days, because they're prorated. And basically, I don't really use the sick days for myself. I save them for my kids, which I think probably a lot of parents could relate to. And I had already run out of my prorated sick days, and it was November. And I remember telling my boss, I hope my kid doesn't get sick, but we got 2 months left in the year. Chances are he's going to get sick. And, I just kind of want to know, what do I do with this? And he goes, oh, don't worry about it. Your kids are sick, you go, we'll figure something out. So they've always kind of had that attitude. So, they've never made me once feel bad about leaving to go get sick kids, basically, or taking them to doctor's appointments or whatever. They've been very flexible. So
it's really great to hear that. In my opinion, in this day and age, I think that if you're a woman and you're an engineer and you're at a place, working at a company that is not going to be that supportive of you, and it's a priority to you to have children and have time with them, I think that you deserve to look around and move on to a place that can, be supportive of you, because, I believe that most people want to work hard and they want to do a good job. And sometimes all they need in order to be able to do that is a little flexibility, like you just described. Yeah,
exactly. I'll tell you the other thing is, I don't feel like I was treated that way at the former company. They would promote work-life balance, but then when you actually had to say, like, oh, my kid's sick, I need to leave. Like, what? You can't possibly. And we lived in Vermont, but both of my parents and my in-laws are back here in Pennsylvania. It's not like we had any family to help us up there, so it's like, oh, too bad. I gotta go, Your kid can't stay sick at daycare. I lost my train of thought here. But I don't think that's even just a woman problem, to be honest. So when I'm teaching, I tend to get the kids more than my husband does, because his company doesn't offer any sick time, and they're not as flexible with him as my company tends to be. So I tend to get the kids if something happens at daycare, they spike a fever in the middle of the day or whatnot. But if I'm teaching a class, like I said, I can't just leave people. They paid good money and they made travel plans to come to Erie to take these classes. So those are the days where my husband has to. And I think that's a fair thing, that you switch off, these responsibilities. And, I actually wish my husband had the opportunity to work at this company as well, because he would want to do those kind of things as well. It's not like he's trying to skirt his responsibility. So I don't even think it's even a woman problem. It's companies in general should try and promote a work-life balance, because that I'm going to be a lot more loyal to this company than I ever would have my last company. And I am. I mean, I go above and beyond. Typically, we don't have to work a lot of overtime, actually, really any. They have stark contrast in cultures between the last company and this company. People don't stay late just for posturing. They pretty much get up and leave at 5, but we work really hard the hours that we're there. On occasion, I've had to come in, on a end here and there. But they've always been very flexible. We'll make it up a different kind of way. So I just think you get a lot more employee loyalty when you treat them, well, like I said, more like family than not, right?
Absolutely. And I'm not married and I don't have kids, so I don't know this from personal experience, but from what I've read, men in more recent years have become more involved as parents, and that's, not to make a completely sweeping remark, but just the trend is headed in that direction. And so you're absolutely right that it's not just a woman issue. That, companies should be, especially in this age where we're doing more technical and creative work, really, that allows for that flexibility. I think the cultures of the companies are having to adapt to that, and it's working out better for them in the way that you just described with better loyalty.
Mm-hmm.
So that's great. And it sounds like you've got a really great husband who's a partner to you.
Yeah. I mean, I'm very lucky with him, and he's very supportive, and we definitely share responsibilities with the kids and the housework because, I work 40 hours a week as well. So I do a lot of the cleaning, but he does a lot of the cooking. And, sometimes my mom, for as progressive as she is, will sometimes make funny remarks about, well, he worked hard all day. Why don't you iron his shirt for tomorrow? Or, and I'm always like, yeah, he's a grown up. He can do it himself. And I joke, but he knows what he got into with me too. I don't think I would have married someone who wasn't okay with it being, a 50-50 split, or me still working after we had kids. That's not the kind of person for me, to be honest. So.
Right. Absolutely. And that reminds me of that. I don't know if you saw this, there was like a laundry detergent commercial going around that kind of hit on that very point where there seemed to be this uneven expectation of, the woman, although she's got the full-time job now too, just like her husband, that she comes home and does all this extra work and kind of trying to break that mold, no pun intended.
Yeah.
Well, Jen, thank you so much for joining us here today on STEMxm and sharing your story and all the great information you gave us about plastics careers. We really appreciate it.
All right, great. Thank you.
Thanks so much for listening to the end. I want to apologize because there was some feedback that happened a couple of times. Hopefully that didn't interrupt the audience getting the great information and perspective that Jen had for us. I'm putting a link in the show notes to several of the items that Jen and I discussed, including the commercial I mentioned at the end. And the main message from that commercial was men and women should share the load. It's worth checking out. You can find today's show notes at STEMxm.com/episode 11. That's STEMxm.com/episode and then the number 11. As always, if you'd like to help the show out, you can go to STEMxm.com/partner. And there's links there to share the show on your social media and everything. And that really helps us get exposure and be successful. And finally today, I'd like to read another review from iTunes. This one is from Sooty0622, and Sooty wrote, STEMxm gives an insider view of how varied and important STEM careers are, and how to find and prepare for a career area that fits. Girls will find role models here, interesting women who believe in what they're doing, and who probably had to buck the status quo to do it. Mel the engineer is relaxed and focused, brings out her guest stories and backgrounds, and is a good role model herself. I have a niece interested in STEM and sent her the link. She loves it. Thank you so much, Sooty, for the kind words and for sharing with your niece. As they say, sharing is caring. All right, guys, thanks again for listening, and stay tuned next week for an episode featuring a mathematician. Vanessa goes by the Math Guru online, and she's amazing. You'll really love that episode, so definitely come back around next week to check it out. All right, I'll chat with you next time in episode 12.
This has been an episode of the STEMxm podcast. Thank you for listening. We would really love if you could pop over to iTunes and give us an honest, positive rating. It helps more listeners find us to learn about STEM careers. Thanks again, cheers, and we'll catch you on the next episode.